Hello. Purpose of this video is to take you through the steps for linear regression for slopes and to find a t-interval for a slope for two quantitative variables. I'll end up redoing this. Check. All right. Hello. The purpose of this video is to take you through the steps from 12.3, which involve creating a t-interval for slopes, and then to interpret that t-interval in terms of tests of significance to whether there actually is a relationship between these two quantitative variables. The data I'm using is the data that we used in class for in L1 is the times in milliseconds of your dominant hand, and in L2 the times in seconds for your non-dominant hand of doing the reaction drill on humanbenchmarks.com. All right, so there were 7 people that participated, and so take you through the steps of this. And what I want to do is just quickly show you from the problem here the conditions that would allow us to create a t-interval for the slope of the relationship between the dominant hand and the non-dominant hand for the reaction test. All right, so to create that interval, we want to go ahead and put the data into our calculator, and then we're going to be looking for these things here. So we'll talk about the linearity of our original data set and that relationship. And then we'll talk about independent, and it is logical to assume that 7 is less than 10% of the population that we're generalizing to, which is high school seniors at Loomis Chaffee. And then we'll also look at the histogram of the residuals, look at the scatter parts of the residuals, and then we can talk about the randomness. We actually took a convenience sample, but we feel comfortable that that our 7 are representative of the seniors at Loomis Chaffee relative to reaction tests. So while we're not random, we do feel it's representative of the population. So let's go ahead and you would have hit stat edit and put, again, dominant in L1, non-dominant score in L2. And so let's just go ahead and look at our original data by going to second y equals, turning plot on, going to scatter plot, L1, L2. And when I hit zoom 9, I'm going to get, and I'm looking for some type of linear relationship. And I think we could say that this is linear. It's not really particularly tight, but there is a linear relationship going on here. So it's worth pursuing to going forward with it. And so then my next step would be to create a linear regression line by going to stat calc and go to linreg number 8, which is the statistical format for the equation, the linear regression equation. So I'll hit enter and L1, L2, and then I'll store it at Y1 by hitting vars, yvars, function Y1. All right, and then I'll go ahead and calculate. And this tells me that my y-intercept would be 27 milliseconds, that my slope would be 0.97, meaning that for each increase of a millisecond in my dominant hand, my non-dominant hand would also increase 0.97 milliseconds. There seems to be a positive correlation. Our positive is 0.59, our R value is 0.59. Our R squared of 0.35 means that 35% of the change in the score of your non-dominant hand can be attributed to a change in the score of your dominant hand. All right, all good review just for basic linear regression. All right, but what we're interested in is trying to figure out is that 0.97, is that so different from 0 that we actually have evidence that there is a relationship going on between that dominant and non-dominant hand in terms of reaction time. All right, so our next step, we've got our model, and then our next step going back here, we've got the linear, the independent, we feel good about. Normal, is there no strong skewness or outliers in the histogram of the residuals? So remember, on your calculator, it automatically calculates the residuals and puts it in the resid list. So if I go and wanted to do an analysis of the residuals, I can turn my plots off in L1 and then go up to L2 or plot 2. And I can look at my residuals, and I can look at them in terms of a histogram. And I go to the resids, which is, you can be accessed by going to second stat, and usually down near the bottom because R is low in the alphabet. Hit enter. That sends it to do the residuals, and again, zoom 9. And I look up, and that's because I left my Y equals on. So I want to turn that off. And now I do zoom 9. Yep. Sorry, forgot to turn my plot on for number 2. Hit on, now I do zoom 9. And you can see no strong skewness there. Doesn't appear to be any outliers. And we can confirm that if we want, if we're not quite sure, by changing the graph to the box plot with outliers indicated. And when I do that, zoom 9 again, and I don't see any outliers there. Okay. So again, I meet this condition here of the normal, that there is no strong skewness or outliers in the histogram of the residuals. Now I want to look at the scatter plots around the residual line where Y equals 0, and about the same at all X values. So again, I go to my calculator. And now I would turn off my second plot. And probably what is easiest is to go to up to plot 1 and then change my L2, my non-dominant score, to residuals. And let's look at the X values of my residuals and see what happens there. Oh, got to turn my this graph on. Now I go to zoom 9. And now you're looking for some level of equal scatter, and this is relatively equal scatter. We high here, but then the low there, pretty equal, and I think I'm good in terms of that. Okay, so now I'm looking at all my conditions. They've all been met. So my next step is to create that T interval. And again, I'll use my calculator, and I can go to second test, and I start up at the bottom and go to linreg T interval. If I say L1, L2, confidence level, say 90%, and send it to my regression equation to Y1 again, and just overwrite what I already have. And so this is telling me that it's between a minus 0.22, meaning a negative slope, and a positive 2.2, which is a positive slope. So my sample slope of 0.97, it generates a confidence interval of minus 0.22 to 2.1 milliseconds. And at the degrees of freedom of 5, because its sample size is 7 minus 2. And so what this is telling me is that, that because my interval contains 0, I would fail to reject the null hypothesis that there is no relationship, meaning the slope is equal to 0, between the score, the reaction time of my dominant hand and my non-dominant hand. All right, so hopefully that helps you go through the process for section 12.3.